Hello, and welcome to all my geniuses. Yes, that's you. Today we'll be looking at this lesson and this topic, naming carboxylic acids. That's the lesson topic, naming carboxylic acids. Let's get into this. Let's go. All right, so first, let's look at parts of a carboxylic acid. Parts of a carboxylic acid. So what are the parts of a carboxylic acid? Well, we could divide a carboxylic acid into two parts. So when we look at carboxylic acid, think of it as two parts. You have the R group, which is the side chain. This is going to change. This can change. And then you have the COOH group, which is the carboxyl group. This is always present. This one never changes. So if you're looking at this picture and you see here, this right here is the carboxyl group. This does not change. And this right here is the side group. Okay, this could be very long, this could be small, but it's the side group. So when you look at a carboxylic acid, we divide it into two parts. We have the carboxyl group, and then we have the side group or the R group, which is going to change. So here, this right here is the expanded structural formula. Whereas this right here is the skeletal formula. This right here is also the expanded structural formula. What is the difference? Well, here, this one is more detailed. It is showing the carbon, it is showing the oxygen, it is showing the hydrogen. Here, this one is a more condensed version. They're saying the exact same thing, but this one is more detailed, whereas this one is more condensed. But these two are the exact same thing. These are the expanded structural formula. So in this video, I am going to show you how to name both of these. Okay, the expanded structural formula and the skeletal formula. When you see them, how are you going to name them? All right, but remember, whenever you see a carboxylic acid, look for the R group and also look for the carboxyl group or the COOH group. Okay. So whenever, so when we, so let's do that. Let's take a look at the expanded formula or the expanded structural formula, and let's see if we can identify the R group, and let's see if we can identify the carboxyl group. And so if you look carefully here, you see this is going to be this is definitely the carboxyl group. Okay, COOH. And this right here, what is this? This is the R group. Okay, the R group here only has the hydrogen. And here we have, again, we have I'm sorry, no, that's not it. Here we have, on this side, here we have the carboxyl group, COOH. And here we have the R group, okay? Notice that this changes, right? First it was just H here. Here we have CHHH. So we see the R group does change, right? But the carboxyl group never changes. This is the next one. This is the carboxyl group, okay? COOH, whereas this one right here, this is the R group. And we could also do it here. So this one here is the carboxyl group, and this right here is the R group, okay? And then this is the carboxyl group, okay? And this one is the R group, okay? And notice the R group changes. First it's just this H, this hydrogen, and then it increases and it get longer and it get longer and it get longer. And so as you can see, the R group does change, but the carboxyl group, this never changes, right? For a carboxylic acid. And here we're just looking at the expanded structural formula. Now let's identify the two parts. Let's identify the two parts when we're dealing with, let me clear our drawings. Let's identify the two parts when we're dealing with the skeletal formula. So again, we still have the two parts, okay? So let me show you. We still have the carboxyl group, okay? This is the carboxyl group. And where you might say, well, where's the carbon? This is the carbon right here. This is the carbon. We don't write it, but that's the carbon, COOH. So that's the carboxyl group. Whereas this right here, okay, this part is going to be the R group. Same thing right here. This is the carboxyl group, okay, COOH, and this right here is going to be the R group, okay? And the same thing for this one. This is the carboxyl group, okay? And then we also have this one right here on this side. This is going to be the R group. Let's go here. This is the carboxyl group, okay? Again, we have COOH, and then this is going to be the R group, okay? And then similarly, for this one as well, this is the carboxyl group, okay? And this is the R group, okay? And then this one again, this is the carboxyl group, okay? And then this is the R group. And then the same thing here, but this is different. This is interesting because if you look at it carefully, right? This is C, right? This is C. The C is implied. This is the carbon. So this right here is the carboxyl group. Now you might say, where is the R group? Where is the R group? Well, we don't show the hydrogens when we're doing we don't generally show the hydrogen when we're doing the skeletal formula. So if we were to include the hydrogen, you could see the hydrogen would be right here. And so this would be the R group. I'm sorry, this would be the carboxyl group, COOH. And this right here would be the R group. Okay. So now you know now you can identify the two parts of the carboxylic acid. That is very important in naming it. All right. You first have to identify that is a carboxylic acid. Is this a carboxylic acid? How do we know if it's a carboxylic acid? When I'm looking at these diagrams, what do they even mean? Now you have a better understanding of what they mean. You know that, okay, when I'm looking at a carboxylic acid, I know that it has two parts, the R group and the carboxyl group. What else is very important in naming? Well, in naming, it's not only important to know the two parts, but in naming it, in naming your in naming your carboxylic acid, it's also important to know that the name the name of a carboxylic acid depends on the number of carbon it has. That's correct. So if it has one carbon, then it's going to start with the prefix. Sorry, if it has one carbon, then it's going to have the prefix meth. If it has two carbons, then it's going to have the prefix eth. If it has three carbons, then it's going to be prop. Then if it has four carbons, it's going to be but. If it has five carbons, it's going to be pent. If it has six carbons, it's going to be hex. Okay, move on. What about seven? If it has seven carbons, it's going to be hept. If it has eight carbons, it's going to be oct. If it has nine carbons, it's going to be non. And if it has 10 carbons, it's going to be dec. And so this is the how you can determine, okay, if we have a certain number of carbons, which prefix we're going to use. Okay, so now we know that carboxylic acid has two parts. We can identify the two parts, and we also know the prefix that we could use when we are trying to um, name carbons. So when we're trying to name these carboxylic acids. So let's move on. So what are the steps to naming carboxylic acids? Well, let's begin. Let's see. The first thing we have to do is we have to identify the carboxylic acid group. Now, we already know it's a carboxylic acid group. We saw that earlier. That's the COOH. We have to identify that so that we could know, okay, we are dealing with a carboxylic acid, right? We don't want to be trying to name a carboxylic acid and it's not a carboxylic acid. So that's the first thing. So once you know it's a carboxylic acid, then you have to count how many carbon atoms it has. All right? And then after you do that, you bring everything together and you use the ending ethanoic acid. All right. Now, the ones that we'll be dealing with today, this is just the three steps that you're gonna need because these ones that we're dealing with are simple. All right. But there are extra steps if we add other things to it. But for the ones that we'll be dealing with in this lesson, this is all the steps that you need to know. Okay, so let's begin with the first one. So, okay, is this a carboxylic acid? Indeed it is. We have, how do we know? Well, we have the carboxylic acid. Sorry, we have the carboxyl group, which is COOH. And we also have the R group. Boom. So we know that, hey, we are dealing with a carboxylic acid. What's the next step? Well, according to our steps, we have to count how many carbons we have. And as you can see, we only have one carbon. So since we only have one carbon, which prefix are we gonna use? Well, we're gonna use meth, right? So one carbon is meth. All right, and then so after that, so we already know it's one carbon, and then now we're just gonna add what? We're gonna add ethanoic acid to it. So one carbon, use meth, plus ethanoic acid. So this is definitely methanoic acid. This is the same thing that we could do when we're looking at this particular skeletal diagram, right? If you look, how many carbons do we have? Well, first of all, is this a carboxylic acid? Yes, indeed. We have the C there, we have the OOH. So indeed, it's a carboxylic acid. Do we have the R group? Yes, we do. This right here, this portion here is the R group, all right? So we have the we have the we have the carboxyl group and we also have the R group. Okay, so we have that. And so how many carbons do we have? That's the question. How many carbons do we have? Well, if you look carefully, we only have one carbon. And so since we only have one carbon, it's going to be methanoic acid. All right. Meth for the one carbon and enoic acid. We always add that at the end of carboxylic acids. Okay, so let's move on. Let's do another one. Okay, but before we move another one, there's a common name. There's a common name to this. All right. So the common name to this particular acid is definitely going to be common name. Sorry, let me put the common name here. The common name is formic acid. That's the common name for this methanoic acid. So you may hear them say formic acid, they mean methanoic acid. If they say methanoic acid, they mean formic acid. All right. So this is the common name. All right. Okay, next, let's move on to another one. Okay. So let me erase this, erase all drawings. And so let's move on to the next one. So what happens when we have not, first of all, is this a carboxylic acid? Indeed it is. We have the carboxyl group, the COOH, so we're good. We have the R group and we have the carboxyl group. All right, so we know that's a carboxylic acid. Okay, great. So my question is, how many carbons do we have? Well, this is a carbon and this is a carbon. So we have two carbons, all right? The same thing here. The same thing here, right? We have a carbon and we also have a carbon. So how many carbons we have altogether? Well, we have two carbons. So what do we do when we have two carbons? Well, remember two carbons is eth. Two carbons is eth. And so all you need to do is combine the two, okay? So two carbons is eth, so it's going to be ethanoic acid. So this is ethanoic acid. All right, so we have one carbon, and next carbon, we have the carboxyl group. So we know we're dealing with a carboxylic acid, so it's ethanoic acid. All right, let's move on. Let's upgrade. But before we upgrade, I have to remember that we have to talk about the common name. The common name for ethanoic acid is acetic acid. All right, acetic acid. So let's move on from this. Let's go on to, let me erase this, clear our drawings. Okay, let's move on to the next one. So what if you have three carbons? What if you have three carbons? What are you gonna do? Okay, so we have one, we have two, we have three carbons. The same thing for this one. We have one, we have two, we have three carbons, okay? We know it's a carboxylic acid. Clearly, this is a carboxyl group. We could also see that this is a carboxyl group as well. So we know we're dealing with a carboxylic acid. Remember, if we have three carbons, what do we call it? If we have three carbons, we're going to use the prefix prop. So it's going to be prop plus enoic acid. So it's going to be propanoic acid. And so that is the name that we could use. Now, the common name for this is propionic acid. That's the common name. But this name that we learned how to do is the propanoic acid. That's what we could call it. So both names are appropriate. This is the common name. All right, so let's move on to the next one. For this one, I want you to try this, right? I think you could get the idea and the general way of doing this. So for this one, I want you to try. Take a moment, pause the video, and try this. What are we going to call this one? Well, first of all, we know that we definitely have the carboxyl group COOH. We also have it here, right? COOH. How many carbons do we have? Well, we have one. This is one. This is two. And you typically start counting your carbons from the carboxyl group. So there's going to be one, two, there's going to be three, this is going to be four. So we have four carbons, the same thing here. This is one, this is two, this is three, this is four. So we have four carbons. So since we have four carbons, what are we going to use? Well, we are going to use bute. So it's going to be butanoic acid. Bute because of the four carbons and enoic acid because it's a carboxylic acid. Perfect. Let's move on from this. Oh, before we move on from this, I keep on forgetting the common name. The common name for this is but butyric acid. Butyric acid. Okay. So let's move on from that. Let's go on and let me clear this drawings. Let's move on. We know we're going to move on now, right? This one is going to be, we're going to move on to 5. And here I have it here already given. And I think you could follow on and understand why I have this, right? Why do I have pentanoic acid? Well, we have pentanoic acid because if you look carefully, first of all, we know that this is a carboxyl group. Okay, we know it's a carboxylic acid because we have the carboxyl group plus we have the R group right here. How many carbons do we have? We have one. I'm sorry, let me start from here. We have one, we have two, we have three, we have four, and we have five. Okay, so this is the fifth. So this is the fifth one. So we also, if you look at this is one, two, three, 4, and 5. So that means that this is definitely going to be pentanoic acid. Why pentanoic acid? Remember, pentagon, right? So if we have 5, this is pent, so it's going to be pentanoic acid. Pent because it's 5 carbons, and anoic acid because it is a carboxylic acid. What is the common name? I'm not going to forget it this time. The common name is valeric acid. The common name is valeric acid. Let's move on from this. Hopefully you get the understanding of this, right? So let's do it without the expanded form. Let's see if you get it. We're gonna just focus on the skeletal diagram. And if we just focus on the skeletal diagram, look at this. This right here is a carboxyl group. This is COOH. How many carbons do we have though? This is C, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So we have 6 carbons. So since we have 6 carbons, what prefix are we going to use for 6? We're going to use hex. Hex. So it's going to be hexanoic. So hex because it's 6 carbons, and anoic acid because it's a carboxylic acid. And so that is the name. Now, the common name for this one is going to be caproic acid. Caproic acid. I think we are pros at this now. We are pros at this now, so that's pretty good. All right. So chemistry is easy. Don't make it hard. So let's move on. So we have this one. How many well, first of all, is it a carboxylic acid? Yes, indeed it is. By now we know this carboxyl group. We know this by heart, right? So we have COOH. All right, we have the C here. That's 1. This is 2. This is 3. This is 4. This is 5. This is 6, and this is 7. So how many carbons do we have? We have 7 carbons. Okay, since we have 7 carbons, okay, 7 carbons. With prefix do we use? We use hept. 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 Okay, so it's going to be heptanoic acid. Heptanoic acid, hept because it's 7 carbons, anoic acid because we're dealing with the carboxylic acid. And the common name for this is N-anthic acid, N-anthic acid. All right, so that is that. Let's move on from this. Let's do this one. So this one should be easy for us at this juncture. We should be pros at this now. First of all, we identify our carboxyl group. This is our carboxyl group right here. We have COOH, all right, COOH, and obviously this part is obviously this part right here, all of this. This is our R group, right? Our R group. And so what we do, let's count how many carbon atoms we have. This is going to be 1, this is going to be 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. So we have 8 carbon atoms, 8 carbon atoms. Okay, so 8 carbon atoms. Okay, so 8 carbon atoms, what does that mean? Well, 8 carbon atoms, that means we are dealing with oct. There's going to be oct because it's 8 carbons, and anoic acid because we're dealing with a carboxylic acid, all right? So octanoic acid. And the common name for this one is caprylic acid, caprylic acid. Now let's move on. We have 2 more. We have 9 and we have 10. So let's move on to this one. So let me clear our drawings. What are we going to do when we have something like this? So let's look at this. This is a big one, right? So first of all, we know we could identify our carboxylic as our carboxyl group. We can identify that. Boom. So we start with 1 carbon, 1. We start with the one that is closest to the carbon. We start off with the carbon that is attached to the carboxyl group. So it's going to be 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and this is 9, all right? And so we're dealing with 9 carbons. We're dealing with 9 carbons, and since we're dealing with 9 carbons, it's going to be non, all right? And so non because it's 9 carbons, and anoic acid because it's a carboxylic acid. So it's non-anoic acid, non-anoic acid. And the common name for this one is pelargonic acid, pelargonic acid. Okay, and last but by no means least, drum roll, please. We're gonna be dealing with, of course, our um 10, all right? So let's count. Let's count and make sure that it's 10, all right? So first of all, we have our carboxyl group, all right? Our carboxyl group we have here. We have C, all right? So that's carbon. So COOH, so this is definitely our carboxyl group. The next part, this part that is on the left, my left, is going to be the R group. So how many carbons do we have? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. All right, so here we have 10 carbons. So since we have 10 carbons, we're dealing with DEC. And so it's going to be decanoic acid, DEC because it's 10 carbons, anoic acid because it's a carboxylic acid. And the common name for this one is capric acid. So that is the first 10 that I gave you all. Um, hopefully, hopefully you learned a lot from this video and you understand what we covered. As we move on in the series, this is definitely the first one. This is the first installation. But as we move on, I'm going to teach you more and more and more. And so thank you for watching this video. I really hope that you gain something from this video and that you understand naming carboxylic acids better. All right, that's a wrap.